let's think about what will happen if we have this molecule. Let's name it. We have 1, 2, 3, 4, 5 carbons, no double bond. So 5 tells us pent. It's pentane, and it has two groups on the number 3 carbon. 1, 2, 3. Doesn't matter which side we start counting from. We have a bromo group and we have an ethyl group. 2 carbons right there. So on the 3 carbon, so we have 3 bromo, 3 bromo, 3 ethyl, 3 ethyl pentane right here. So we have 3 bromo, 3 ethyl pentane dissolved in a solvent of, and this right here, it's an alcohol, and it has 2 carbons right there. 2 carbons, so meth-eth, so it is ethanol. So this right there is ethanol. So let's think about what might happen if we have 3 bromo, 3 ethyl pentane dissolved in some ethanol. Now, ethanol already has a hydrogen. It's not super eager to get another proton, although it does have a partial negative charge. It is polar. Oxygen is very electronegative, so it has a partial negative charge. So maybe it might be willing to take on another proton, but it doesn't want to do so very badly. So it's actually a weak base. So ethanol right here is a weak base. So it's not strong enough to just go nabbing hydrogens off of carbons like we saw in an E2 reaction. So it's just going to sit passively here and maybe wait for something to happen. Now, what might happen? Well, we have this bromo group right here. We have this bromine, and the bromide anion is actually a pretty good leaving group. It's a fairly large molecule. It's able to keep that charge because it's spread out over a large electron cloud. And it's connected to a tertiary carbon, right? This carbon right here. This carbon right here is connected to 1, 2, 3 carbons. So if it were to lose its electron, if it were to lose that electron right there, it would be, it might not like to do it, but it would be reasonably stable. It's within the realm of possibilities. It could occur. So maybe in this first step, since bromine is a good leaving group, and this carbon can be stable as a carbocation, maybe, and the bromine is already more electronegative, so it was already hogging this electron, maybe it takes it all together. So let me draw. So neutral bromine has 1, 2, 3, 4, 5, 6, 7 valence electrons. Maybe it swipes this electron from the carbon, and now it'll have 8 valence electrons and become bromide. So what happens now? And of course, the ethanol did nothing. It's a weak base, wasn't strong enough to react with this just yet. So what is happening now? So this is going to be the slow reaction. So right here, what I said, this isn't going to happen super fast, but it could happen. This is actually the rate determining step. Rate determining, not determining. This is the rate determining step. So what happens after that? So let me just paste everything again. So this is our setup to begin with. But now that this little reaction occurred, what will it look like? Well, the bromine has left, so let me clear that out. Let me clear out the bromine. Edit, clear, and actually took an electron with it, so it's bromide. So let me draw it like this. So I'll do it in blue. So this is the bromine. So the bromine is right over here. It had 1, 2, 3, 4, 5, 6, 7 valence electrons. It swiped this magenta electron from the carbon. Now it has 8 valence electrons. It has a negative charge. The carbon lost an electron, so it has a positive charge. And it's, somewhat stable because it's a tertiary carbocation. So now let's think about what's happening. And I want to point out one thing. In this first step of a reaction, only one of the reactants was involved. This rate determining, the slow step of a reaction. If this doesn't occur, nothing else will. But now that this does occur, everything else will happen quickly. But in our rate determining step, we only had one of the reactants involved. So it's analogous to the SN1 reaction. But what we're going to see here is that we're actually eliminating. And we're going to call this an E1 reaction. We're going to see that in a second. Actually, the elimination has already occurred. The bromide has already left. So hopefully you see why this is called an E1 reaction. It's elimination, E for elimination, and the rate determining step only involves one of the reactants right here. It didn't involve, in this case, the weak base. But now that the bromide has left, let's think about whether this weak base, this ethanol, can actually do anything. It does have a partial negative charge over here. It does have a partial negative charge, and on these ends it has partial partial positive charges. So it is somewhat attracted to hydrogen, or to protons, I should say, to positive charges, but not so much that it can swipe it off of things that aren't reasonably acidic. Now that this guy's a carbocation, this entire molecule actually now becomes pretty acidic, which means it wants to give away protons. Or I guess another way you could view it is that it wants to take electrons, depending on whether you want to use the Bronsted-Lowry definition of acid or the Lewis definition. Either way, it wants to give away it wants to give away a proton. It could be this one, it could be that one. It has excess positive charge. It wants to get rid of its excess positive charge. So it's reasonably acidic, enough so that it can react with this weak base. And what you have now is a situation where on this partial negative charge of this oxygen, let me pick a nice color here. Let's say this purple electron right here. It can be donated, or it will swipe the hydrogen proton. Then hydrogen's electron will be taken by the larger molecule. In fact, it'll be attracted to the carbocation. So it will go to the carbocation just like that. Now, in that situation, what occurs? What's our final product? So let me draw it here. So this part of the reaction is going to happen fast. The rate determining step happened slow. The leaving group had to leave. The carbocation had to form. That's not going to happen super fast. But once that forms, it's not that stable. And then this thing will happen. This is fast. So let me just paste everything. Actually, let me just paste everything again. Aid the drawing. So now we already had the bromide. It had left. The bromide had left. And now the hydrogen is gone. Let me clear this. The hydrogen from this carbon, from that carbon right there, is gone. Now this electron, that electron is still on this carbon, but the electron that was with this hydrogen is now on what was the carbocation. So that electron right here is now over here, and now this bond right over here is this bond. We formed an alkene. And now what was an ethanol now took a hydrogen proton and now becomes a positive cation. So let me draw that. So this right here, this electron ends up being given. So it's no longer with the ethanol. It's no longer with the ethanol. So it's no longer with the ethanol. It gets given to this hydrogen. It gets given to this hydrogen right here, that hydrogen right there, and now they have formed a new bond. And since this oxygen gave away an electron, it now has a positive charge. It now has a positive charge, and all along the bromide anion had left in the previous step. So the bromide anion is floating around with its 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, and then it has this one right over here that makes it negative. And then our reaction is done. We had a weak base. And a good leaving group, a tertiary carbon, and the leaving group left. We only had one of the reactants involved. It was eliminated. And then once it was eliminated, then the weak base was then able to take a hydrogen off of this molecule, and that allowed this molecule to become an alkene, formed a double bond. This is called an and I already told you, this is an E1 reaction. E for elimination, in this case, of the halide. 1 because the rate determining step only involved one of the molecules. It did not involve the weak base. We'll talk more about this, and especially different circumstances where you might have, well, the different types of E1 reactions you could see, which hydrogen is going to be picked off and all of the things like that. And we're going to see when E1, E2, SN1, or SN2, what's kind of the environment or the reactants that need to be there for each one of those to occur in different circumstances.